ahead and give a demo of OpenShift AI. In this demo, we'll have a hypothetical insurance company that's looking to improve their insurance claims process. Let's go ahead and show some examples of what we will be doing. Here, we'll be using an LLM to summarize the text of emails that have claims information. We'll pull out things like date, vehicle, and location. We can also look at the sentiment of the email. Is this customer frustrated? Are they being polite? This may help in how we process and order different claims coming in. That's an example of generative AI, but we can also use predictive AI. We'll take images coming in that are part of the claim process and assign different severity of the damage on the vehicle. With that, let's go ahead and get started. Go ahead and create the project. Here I have an instance of OpenShift AI open. Come into projects. We'll create a new project and we'll call this user 9 in my case. And now we have the project view. Now we have a variety of different services and tools here that we can use. We have access to our workbenches, where the experimentation and training of our models will take place. We have our local cluster storage. And then we also have data connections that can be used to connect to external or internal S3 buckets. We have pipelines that can be used for a CI/CD or AI ML ops type of process. And lastly, we can also host and serve our models here from this particular project dashboard. We'll come up here and start with a new data connection. All right, we've populated our data connection and we can go ahead and add it. This will connect to a S3 bucket that's hosted within the cluster using Minio. Now let's go ahead and create and launch our workbench. We can come over here and press the Create Workbench button, and we will title this My Workbench. For the image, we'll use a custom image that we've created here called Insurance Claims Processing Lab Workbench. This is one of the unique features of OpenShift AI. We allow you to take our base images and workbenches and add different packages on top of it based off of the requirements you need for your own experimentations. We're going to keep the size in this case standard. And here, if we wanted, we could assign a GPU to this particular workbench. In this case, I don't need it actually for this particular exercise, but I wanted to show you how that would work if we were working with something that would require a GPU. We can assign environment variables to the workbench and also cluster storage. In this case, I'll go with the default values that we have set. Here is how we can pull in different data connections. We'll utilize the data connections we've had here within the workbench environment. We'll go ahead and create the workbench. All right, our workbench is done loading. Let's go ahead and load the notebook. Come here to the open. Here I'll log in as user 9. And we'll wait a moment for the Jupyter lab instance to load. All right, our notebook is ready, and let's go ahead and pull in some code. I'm going to come over here to this Git tab, come down to Clone Repository, and bring in our code. I'll bring our view up a little bit more just to make this a little more readable. And then here we can look at our content. We'll go through a couple of the exercises in here. Let's go ahead and do the first exercise within this demo. Within this workbench, we have access to a Mistral 7B LLM. This is a moderately small to medium-sized LLM, but it's quite powerful. We'll show here how this LLM can be used within this demo. Within this view, we have our notebook. There are a variety of code blocks and annotation blocks that allow data scientists to both experiment and train models. This is a way for them to have their annotations, their code, and their results all in one place. They can also collaborate with other team members within this notebook. This is a powerful tool during experimentation or when a model needs to be presented to different stakeholders, where it can be shown both in an annotated form and show the results all within one place. Let's go ahead and step through this and show what happens. Here, I'll step through the different code blocks. We'll go ahead and bring in the necessary libraries. And here we're using the popular open source tool LangChain to host the LLM. We will connect to the LLM. I want to highlight one of the parameters here. Temperature is how we tell the LLM how firm on its results we want it to be. How much certainty does it have? If this value is very low, it will provide the most certain result for whatever piece of text it provides next when coming up with content. This is really good for a chatbot where you want a level of certainty in the types of results being provided. But let's say you wanted to write a story or a poem. This is where you could experiment with this value and bring it up and allow the LLM some creativity. Eventually, if you keep pushing this number up, it will just be a garbled mesh of text. So there is a line there that goes from creativity to really nothing. We'll go ahead and look at the next section for the template. Here we have a form of what we call prompt engineering. This template is letting the LLM know how we want to interact with it. We're setting some guidelines. We're saying things like, don't be racist, don't be hostile, be polite and concise in your conversation. This is used in all forms of LLM and is a very powerful tool to get the accuracy that you're looking for in your results. We'll go ahead and create this, and we'll ask it, what is artificial intelligence? And here we have a result. Now, let's mix this up a little bit. Let's ask it, what is Red Hat? Now here we have a result of what is Red Hat. Let's move on to the next section. Here, we're going to take in one of these claims, or emails in this case. Let me go ahead and show you what this looks like. Right now we have these JSON files, and we have this pretty long-winded email that we need to summarize and pull critical information out of. Let's go ahead and do that. Go ahead and do similar things that we did before. Bring in the necessary libraries, substantiate the instance of this particular LLM. create our template, and then we'll loop through these JSON files and have it give a summary of the email. Here we have the original email, and then down here we have the LLM giving a summary. Here it's telling us who sent the information, where was it that the accident took place, and some critical details about the accident. We were able to condense this by about 70%. Let's move on to the next example. Here, we'll extract exact information from the email, like location, time, and also the sentiment of the email. Let's go ahead and give it a try. Here we have the original email, and you can see here we're generating the sentiment, location, and time. Here it says the sender of this claim is expressing extreme dissatisfaction in the handling of their claim. The location is at Maple Street and Oak Avenue, and then the time is January 15th at approximately 3:45 p.m. Let's go ahead and move on to the next example. This is my favorite example for this whole demo. We're going to show you a comparison between the model that we've been using so far, Mistral 7B, versus the FLAN T5 model. This is a very small model, which doesn't require any AI accelerator like a GPU or NPU, and it's more experimental. It's meant for very particular use cases, which what we're going to show here, this wouldn't be one of them. But let's go ahead and look at a comparison. We'll go ahead and create two instances, one of our Mistral 7B and one of our FLAN. Keep the same template. And then we'll do the same thing as before. Here we have the original email. We have the Mistral 7B, similar to what we just saw in the previous example. And then we have the analysis from the FLAN T5. Sentiment is negative. The location is Evergreen Auto Repair, and the time is a day. This is an example of why you need to be careful how you pick your LLM for your particular use case. You will always be balancing between the quality of the model and the capacity of the model. How much memory does it take? How much CPU? How much storage? This is the balancing act that we have to work for on when we're choosing an LLM to solve a particular problem. That's it for our LLM example. Let's move on to the predictive AI side. We're going to use the popular YOLO model. You only look once. This is a popular open source model for image detection. Let's go ahead and show you what it looks like. We'll load the model, and then we'll bring in an image of a vehicle, in this case, a car. We'll now run the model and run a prediction off of this particular image. Now, it may be hard to see, I'll highlight here, but it has detected one car here within this image. What happens if we try more vehicles? Let's give it a try. Here we have an image of multiple vehicles. Now, in this case, it will not be able to pick up all of these vehicles. For us to be able to do that, we would have to go through many different training cycles and build on this particular YOLO model. But let's see what it can pick up. You'll see here that it's found 17 cars and one truck. This is pretty hard for us to notice, But there's ways that we can add some visual cues to see what the model is seeing. Let's go ahead and give that a try. We'll go ahead and create some boundary boxes around the vehicles that have been detected. Let's go ahead and create that. Here it's calculating what the boundary box needs to be based off of the information provided by the model. You can also see what types of objects this particular model has been trained on. You'll see we have cars and trucks and bicycles, but we also have things like cups and surfboards. Now let's go ahead and show the visuals of this. Here, we have a boundary box being created around the car that's detected. The number provided is the accuracy of this being the object that it believes it's seeing. In this case, it's 91% sure that this is a car. We can now take a look at the image of all the different vehicles, and you'll see that we have the 17 cars and the 1 truck. There are a variety of different errors here, and you'll see that the confidence rating is ranging from anywhere from high 80s to potentially the low 30s, with especially the images that we're seeing towards the back of the image. Now, this is pretty common. This is a vanilla model. We have not trained it on this specific type of image. And if this was, let's say, a transportation authority, they would probably have tens of thousands of these images that they're using to train a model to bring these numbers up from the low 30s, hopefully up to the mid 90s. Let's go ahead and go to the next example. Now we're going to take that model and we're going to add some images of accident data that has been labeled. We've given it certain severity, and then we'll provide it a new image of an accident and allow it to determine the severity of the accident. We'll go ahead and bring in our model. We'll pull in our images and our training data. And then we'll start the retraining of the model. It'll go through a few iterations here. And we'll give it a moment here to finish. All right, our model has finished training. Let's go ahead and move on to the next example. We'll go ahead and test the model that we just created. Let's go ahead and pull it in. All right, we have an image of an accident and a boundary box and severity rating. In this case, it is labeled it severe with an accuracy of 86%. This is an example of what is possible within the experimentation and training phase of an MLOps process within OpenShift AI. Now, we've built this new model, but you could also then host it within OpenShift. It doesn't need to be hosted within the workbench itself. You could put it within OpenShift AI and what we call infer the model and make it available to different applications internal to OpenShift and external. These are some powerful examples of what is possible within OpenShift AI.